Hi, you guys, it's Mrs. Mafucci, and right now I want to continue looking at the characteristic spectra of elements. The spectra produced by all the elements serve as fingerprints. Have you ever wondered how scientists know what's present on various stars and planets? How do they know, for example, that the sun is mainly helium? Well, right now up here, I'm showing you what helium looks like when gaseous helium is exposed to a high electrical discharge. And right now you see that white, yellowish color right there, but it's not that definitive. Like, what color is it? You can say it's whitish yellow. And like when we did the flame test before, you could just say green, blue, red. Well, I have something here called a diffraction gradient. And what the diffraction gradient does, it works like a prism, and it's going to separate this light into all of the component wavelengths of light. So I have to put this in front of my camera. Oh, look at that. So you don't see that purple when you just look at the helium. You don't see that purple at all. So you see that helium, that whitish yellow light, is actually composed of some purple, some green, some yellow, and some red. Each of those lines represents a specific electron transition going from higher energy levels to lower energy levels. Remember, purple, short wavelength, high energy. Red, long wavelength, low energy. Well, I'm going to pause this and now put in neon. And I'm going to let you see how I change these spectrum tubes. I'm taking out the tube. You don't actually see anything, do you? But you can hear me working. And now I'm going to turn on neon. Here's neon, the characteristic bright red light that we see in a lot of signs. Well, let's put the diffraction gradient in. Do you see all those red lines, the yellow lines? You don't see too much blue or green, do you? Now, chemists can actually find the specific wavelength of each of those different lines, and from that, calculate the energy transition. How much energy was lost when the electron moved from a high energy level to a lower energy level in order to produce that wavelength of light?